10.6, Finding Segment Lengths in Circles. We're going to take a break from the angles and all the arcs, and we're going to go to the segments, lines, including chords, tangents, secants, that we can draw with a circle, and we're going to find the lengths of those lines, or line segments today, I should say. So a couple things here in our vocab. Segments of a chord. What's going to happen in our circles if we have a circle and we have two chords that intersect each other? We're going to have segments of the chord. So on this one chord, here's one of its segments, here's a segment. On this chord, this one's a segment, and this one's a segment. So we're going to take these chords and kind of cut them up into different segments. We're going to have secant segments and external segments, and these two go together. So if you have a circle and you have some secants coming through the circle, remember a secant goes through a circle in more than in the two spots and leaves the circle. The secant segment is going to be this segment inside the circle that's really looks like a chord if you just took part of it. And then the external part of the secant is the outside part. And as we go through our theorems and work today, you'll see kind of why they wanted to look at those two different words. Okay, so we're going to start with two chords in a circle and figure out how we can find the length of those. All right, so it says in theorem 1014, segments of a chord, if two chords intersect in the interior of a circle, then the product of the lengths of the segments of one chord is equal to the product of the lengths of the segments of the other chord. So when we're filling in over here, EA, which is from this chord going this way, is going to multiply by its other segment, EB. And then EC, which is the one kind of going up to the right, will multiply by its other segment, ED. So we're going to get kind of like a part times part equals part times part. And what's important here is we realize that the part 1 and part 2 need to come from the same chord. Okay, so these are from the first chord. And then it's going to equal part times part of the second chord. So make sure parts of the same chord are what gets multiplied together. You don't want to mix and match between the two chords, but the two parts from one chord multiply together and the two parts from the other chord multiply together. So let's go ahead and try this problem in example 1 as an example. So you can see in here we have two chords intersecting in our circle. So filling in as far as the names of them, we have NK, which is this short little segment over here, going to multiply by NJ. And that leaves us on the second one with this small part NM, multiplying by the longer part NL. Okay? And just like normal, I usually don't make you write that line, but just keep in mind that's where it's coming from. It's nice to come back to these notes and see where those names come from. So they already filled in NK is X, NJ is X plus 5. We're going to fill in NM, which is this little part down here at the bottom, this X plus 1. And then the NL, which is the top part there, which was X plus 3. If you can make sure you check your notes there, I think it says X plus 3. Okay. Everything's filled in, it's algebra time. You will see a lot of algebra today. We're going to hit a lot of those algebra rules, get into quadratics, so please, please, please brush up on them. Make sure you're practicing, because when it comes to the test, you will have some algebra involved. On the left side, when I have x times x plus 5, I'm going to distribute and get x squared plus 5x. On the right side, because I have two binomials, don't forget that great method we have to follow, and that's we need to FOIL it. So I'm going to do my first times my first for my f. That gives me x squared. I'm going to do my outsides, x times 3, and it gives me 3x. I'm going to do my insides, which is positive 1 times x, which gives me 1x. And finally, I'm going to do the two last, which is 1 times 3, which is 3. All right, algebra. When I move to get those x squareds by themselves, they're going to cancel when I subtract them on both sides. So on the left side, I still have 5x. On the right side, I now have 4x plus 3. Subtract 4x, and I'm going to get x equal to 3. Okay? I'm going to often stop us at that point. Most of your homework, you're going to stop once you find x. But in this case, we need to be careful. They did tell us to find ML and JK. So we have some plugging in to do. I look for ML back at my picture. ML is the full line from M to L over here. The bottom part of MN here was X plus 1. And the top part from N to L was X plus 3. So I'm going to plug in my 3 for those X's. And I get 4 plus 6, basically, if you think of it that way. 4 plus 6, and I get a length of 10. All right, for JK, my second chord, I have an X, and I have an X plus 5. If I plug in my 3 for the one spot, and then a 3 plus 5 for the second one, that's like a 3 plus 8, and I get 11. Now, what I want you to really notice here is, are my chords congruent? No, that's not what my theorem tells me. What my theorem tells me is the parts of my chords are congruent. So if I go back to this line right here and I say 4 times 6, that's 24. I look over here on the right side, I have 3 times 8, that's 24. So that checks with my theorem. My parts of one chord equal my parts of the other chord when they're multiplied together. But the chords themselves are not the same length. That's important to realize, is it's their multiplication that should be the same, not necessarily their length. All right, let's move on to page 2 and our second rule. All right, on page 2 here with our second rule, we are talking about two secants, okay? And I will say that our secants are cut off and they are just segments right now. We know secants can have arrows and go on forever. They have to pass through the circle twice. And these definitely still pass through the circle twice. I see from E to B, I see that they pass through twice and then have this external part. E to D pass through twice and it has an external part. So they are secants because they cut through the circle twice and come outside of it. So my rule here says if two secant segments share the same endpoint outside a circle, then the product of the lengths of one secant segment and its external segment equals the product of the lengths of the other secant segment and its external segment. So I can fill in the blanks for you here and just tell you EA equals times EB equals EC times ED. And my guess is that sounded like a bunch of mumbo jumbo. So just like I did with those arcs and those angles when I would tell you like in equals 1/2 arc plus arc, I've kind of come up with these little sayings that help us to remember and make it a little bit easier to remember. What am I trying to plug in? What are these theorems actually trying to tell me? So on this one, if I consider on the already see, I put this note, I want to do out times whole equals out times whole. And of course, this out and whole go to the first secant. And really, it doesn't matter which one's the first, which one's the second, just choose one. And that's going to equal the out times whole of the second secant. Okay, so if I come back here, EA is my out, if you see that out, and EB is the whole thing. Not the inside part, it's the whole thing. EC is the out part here, and ED is the whole thing. So that's what you need to make sure that you're checking for, is use the whole thing. So let's try our first example here and do this setup. They wrote down here first, but I'm going to stress this one. This is out times whole equals out times whole. So they started on the top. The RQ here is out, and that's a length of 6. And the whole is RP. Now, they did 6 plus 4. Don't be afraid to just make that 10, okay? And then on the bottom secant, we have the out, which is RS, or 5. And this is where we have to be careful. And the whole thing, we have to add these two together. Well, one part is X, and the other part is 5. So I would just part X plus 5, because I can't add them if they're not like terms. So over here, I'm going to get 6 times 10. Over here, I am going to have to distribute here, because I can't add x plus 5. So I'm going to distribute and get 5x plus 25. Well, 6 times 10 is 60, equals 5x plus 25. Subtract 25, and I get 35, equals 5x. And divide by 5, and x is going to equal 7. Okay? So just a quick reminder, if I put 7 up here, what this theorem tells me, if I do 6 times 10, because 6 times the whole thing, it's going to equal 5 times this whole thing, and 5 plus 7 is 12. Well, 6 times 10 is 60, 5 times 12 is 60. So the product of the out times the whole equals the product of the out times the whole. But that doesn't mean my two lines are the same length. It means their relationship of out times whole is equal to out times whole. All right, let's move my page up here. And we're going to try two more using these two theorems. And again, part of your job is going to be sorting through which of these setups do I use and which reason. So on my first one, on number 1, I see two chords. So when I see two chords, I'm going to think part times part equals part times part. Okay, and remember, I want to get parts from the same chord on the same side. So from my one chord, I'm going to use this 5 and the 12. So from the same chord, those two need to stay together. And my second one is going to be from the same chord, 6 times x. And remember, you can write those 12 times 5 or x times 6. It doesn't matter as long as there's two parts from the same chord are together. 5 times 12 is 60. 6 times x is 6x. Divide by 6 and x equals 10. And it did tell me I can stop on this one once I find the value of x. For number 2, I don't see chords at this time. I see secants. So anytime I see secants, I'm going to do an out times whole equals an out times whole. There's a good chance if you found a geometry student from last year, they might remember ow equals ow, right? Ow, ow. That's what we're doing right here. So on the top secant, my outside portion there is 6. My whole thing, now be careful, the whole thing when I add it together is 14. Don't put that 8 in there. I want the whole thing. It doesn't say oi, oi, oi. It says out times whole equals out times whole. No insides here. On my second secant on the bottom, the out is 7. Now be careful here. The whole has to be the two parts added together, and because they're not like terms, I just have to leave it x plus 7. Well, 6 times 14 is 84. On the right, I'm going to distribute. 7 times x is 7x. 7 times 7 is 49. Subtract 49. I get 35 equals 7x. Divide by 7, and x equals 5. Again, my chords are not congruent. My secants are not congruent, but those relationships of part times part equals part times part or out times whole equals out times whole. All right, time for page 3 and our third rule for the chapter, or for this section, I should say. The chapter has lots of rules. All right, we have one more scenario here. By the way, this is our last one. This is if I see a tangent segment. So I have a tangent segment. Remember, it only touches the circle once on the outside. And it joins with a secant segment that touches the circle twice. It says if a secant segment and a tangent segment share an endpoint outside a circle, then the product of the lengths of the secant segment and its external segment equals the square of the length of the tangent segment. All right, what is this really saying? One thing I want to remind you of is when we did two chords, we did part times part equals part times part. When we did two secants, we did out times whole equals out times whole. Every time we multiplied two things together on either side of the equal sign. Well, when I look at this tangent, there's really only one thing. So what we do is we multiply it times itself. So it's going to be like tangent times tangent. Okay, that's kind of what we're doing on the outside. That's my EA squared. When I have something of the same, I can just say squared instead of times itself. Then I'm going to multiply by this outside segment of EC times the whole thing ED. Okay, so I get tangent squared equals out times whole. So my tangent's by itself, but I need to multiply two things, so I multiply it times itself. Tangent squared equals out times whole from the secant. Okay, so that's where my setup comes from on this one. All right, let's look at my next problem. And I will tell you, as far as setup, it's pretty easy to follow this one. But where we're going to run into some extra work on this one is the algebra involved. Okay, so have your calculator handy, be ready to rack that brain to figure out all the algebra we can do. Okay, when I look at this picture, I see a tangent segment and I see a secant segment. So I use that formula or that setup, tangent squared equals out times whole. I'm going to stress to you, and I even put it on the directions on the worksheet for this section, please, please, please write your setup every time. And what I mean by that is something like this. You look at the picture and say, I see a tangent, so it's got to be tangent squared equals out times whole. Then when you start to fill them in, you have a better chance of putting in the right information because you remember which setup you're using. So my tangent here is this RQ, and it's 14. My out segment is just X, and my whole thing, remember, we add it together, and we get X plus 12 when I add it together. All right, so 14 squared, we get a 196, and I'm going to distribute my X squared plus 12X. All right, we didn't get anything to cancel like we did earlier. It looks like we have this to work with. So what we have is a quadratic. If you remember this from algebra, a quadratic is anything that has x to the second degree, and we have different ways we can solve it. So in the margin, you can see the 5 different ways to solve a quadratic. I know I've gone through this list for you different times throughout the year, but I just stated them down here so you can see them. 5 ways to solve a quadratic. We can graph. By the way, a quadratic is a parabola. So if we would graph, we're looking to see where it crosses the x-axis. It's a method that works if it crosses the x-axis, but it can be messy, it can be time-consuming, and I'm going to be honest, we're not going to pull out our graph paper to do that. So it is an option, we're not going to do that one. If there's no x term, square roots is a great way to solve it, but I can see my x term right over here, so that's not going to work right now. Completing the square is a method you learned in algebra. I'm going to be honest, again, it's a lot of work, and it's probably not our best option here, which leaves us with 2 of them, factoring and quadratic formula. And I'm going to be honest, these are the 2 I want you to choose from when you're working on your homework. And I'm going to be honest, you're going to need them, okay? Because you are going to have some quadratics in your homework if you do it correctly. So be ready to do these. Now, as I like to tell kids all the time, factoring should be your favorite choice. I know most of you leave algebra and don't say factoring is your favorite, but to be honest, if it works, it is the quickest and most efficient way to do these problems. The other option is quadratic formula. Quadratic formula will work absolutely every time. You never have to question. If you can plug into the formula correctly, it will work. Notice though, either factoring or quadratic formula, the most important thing we have to do is we have to have our equation set equal to 0 to be able to do either one of these. Right now I have 196 on the left side. So I'm going to move that to the right side by subtraction. I have x squared plus 12x, and now I'm going to subtract this 196, and what it's going to do is just hang out back here because none of those are like terms. All right. Factoring. To see if we can factor, we would have to look at this, our terms. Remember this 1 that's in front of 1, and I'd have to see, are there factors of 196 that subtract to make 12? I'm going to save us a little time here tonight and tell you it doesn't happen on this one. Okay, it's not going to. So we're going to choose the second way, which is the quadratic formula. Okay, do you remember the quadratic formula? Do you have some fancy little song you sing in your head to remember it? Or do you just remember that the quadratic formula is negative b plus or minus the square root of b squared minus 4ac all over 2a. Okay, that's a lot of mumbo jumbo. What does it mean? Remember, when we set our equation equal to 0, we have 0 equals, and we might have a number in front of the x squared. If we do, that's our a. We might have a number in front of our x. If we do, that's our b. And we might have a constant that has no variable on it, and that would be our c. These are the numbers we're looking for to plug into this quadratic formula. Okay? So, in some ways, you're like, well, you give me a formula, it should be easy. It can be, but it can be a lot of work too. So we're going to try to go through this slowly. I need you to follow along and see where we're finding all of these. Okay, so a is the number in front of x squared. So I come over here to x squared. What's my number in front of it? Now, two choices. A lot of people want to tell me there's nothing there, so it's a 0. But be careful. If it was a 0 times my x squared, I wouldn't have an x squared and it would disappear. So it can't be 0. What's my invisible number in front of x squared? It's got to be 1. My invisible number that isn't required to be written is 1. All right, my b is my number in front of my x, and I always include the sign with it to make sure I know it. And so that looks like a positive 12. You can write the positive, but what I really want to stress is if there's a minus or a negative, make sure you include it. And c is going to be this constant at the end. Now again, look carefully there. I see that negative, so it's negative 196. Okay, those are the three variable or those three numbers that I'm going to plug into this quadratic formula. Okay, by the way, I like to say negative b to start out with. Your teacher or who you learned this off of may have said opposite of b. It doesn't matter which way, they kind of go the same way. So I take my b, which is 12, and I go opposite. So I have negative 12 out front. This plus minus is always there. It's part of the formula. Big square root. All right, I'm plugging in b again. So I plug in 12 squared. I always have a minus 4 that never goes away. It's part of the formula. I plug in my a of 1 and my c of negative 196 all over. That division bar is the entire length, all over 2 times a, which is 1. Okay, we've got it plugged in. Now we have to work on getting a number from it. Negative 12 isn't going anywhere. Plus or minus isn't going anywhere. I like to do inside my square root in 3 pieces. Okay, here's my pieces. Let me change colors so you can see it a little better. Okay, here's my first piece. I like to do my squared. I have 12 squared. That's 144. My next piece. Yeah, that's my next piece. All it is a minus sign. Put it down there. I find that if I put that minus or that subtraction sign, kind of like a negative, it all works the same way, kind of. If I put it as its own sign, it keeps me from making too many mistakes. My third piece is these 3 numbers. Notice they're side by side. If those 3 numbers are side by side, I need to multiply them together. So get out that calculator. 4 times 1 times negative 196. I just got a negative 784. So parentheses, because this is my third piece, negative 784. Okay, those are my 3 pieces inside my quadratic formula, or inside the radical. Those are important. All over 2 times 1, which is 2. Okay, now I'm not done inside that radical, but I'm ready to do, I am ready to combine things. So since I have 144 minus a negative 784, a minus a negative becomes a plus, and I'm going to do 144 plus 784, and I got 928. Okay, I'm going to come down here to the I don't want to mess up too much of what they wrote here, so I'm going to put negative 12 plus or minus the square root of 928 all over 2. Okay. Quick reminder, when you have a quadratic and there's a degree of 2, that means I should get 2 answers. And I have 2 answers. So how do I take this mumbo jumbo and make it 2 answers? Well, here's my 2 answers. I can have negative 12 plus the square root of 928, all divided by 2. And I can have negative 12 minus the square root of 928, all divided by 2. Okay. So let's plug those in the calculator. Let's figure out what my 2 answers are. So I type in negative 12 plus the square root sign. Remember on my calculators you would use that second key of 928. Please, please, please close the parentheses of that radical or that square root, okay? And now I divide the whole thing. I'm going to tell you what, on your calculator do it this way. Do negative 12 plus the square root of 928 and hit enter. It's going to give you this big decimal. Then divide that decimal by 2. Okay? And I get a positive 9.2. I rounded it, by the way. It doesn't come out whole. All right, let's try the second one. Negative 12 minus the square root of 928. Hit equals. Get that decimal. It's a big decimal. Divided by 2. Okay, I get negative 21.2. Okay, peek back up at the picture. Can I make RS here equal negative 21.2? No, no length can be negative. So the answer I want to work with is this positive 9.2, because lengths cannot be negative. That's what's going in this blank right here. So use only the positive solution. Okay. Guys, our real big thing is doing tangent squared equals out times whole, but we kind of got into this algebra as well. Okay. Let's try the bottom one. Okay. And here's one hint I want to give you. I think most of them in my homework factor. So I think that should make it easier. But if you want to practice the quadratic formula, everything that factors also works for the quadratic formula. So you can do it both ways. Okay, so let's go ahead and try number 3 here. I am trying to find the length from J to K. So I'm trying to find this X right here. So I need to always look at my pictures on my homework and what I have right now and say, do I have 2 chords? Do I have 2 secants? Or do I have a tangent and a secant? Well, this segment JM out here is only touching the circle once on the outside. That's definitely a tangent. So right away, I'm telling myself I'm going to use tangent squared equals out times whole. Okay? So my tangent segment is 8. That's with my tangent. My outside segment is X. Now be careful, the whole thing is this entire segment, and that's going to be the X plus 6. All right, algebra time. 8 squared, 64. Distribute X times X is X squared. X times 6 is 6X. It looks like, once again, I have a quadratic. I want to set it equal to 0, so I'm going to subtract 64 on both sides. I'm going to get 0 equals X squared plus 6X minus 64. All right. Are there factors of 64 that subtract to make 6? Unfortunately, no. So we're going to do another quadratic formula here. If nothing else, hopefully you're seeing it and you're getting a little practice with it. Okay, so I'm going to first identify A is the number in front of my X squared. That's that invisible 1. B is the number in front of my X. That looks like a positive 6. C is my constant back here, which looks like negative 64. So that's what I'm going to use in my quadratic formula. All right, here we go. Opposite the B. So I start with negative 6 plus or minus the square root. I do another B, so I do 6 squared minus 4, always minus 4, times my A, which is 1, times my C, which is negative 4, all over 2 times my A, which is 1. Outside, that negative 6 isn't going anywhere, plus or minus isn't going anywhere. My 3 pieces, 6 squared, 36. Always write down my minus, that's piece 2. Piece 3 is all 3 of these multiplied together. 4 times 1 times negative 64. Gives me a negative 256. All over 2 times 1, which is 2. I have a negative 6 plus or minus. When I do a minus and negative, 36 plus 256 becomes 292, and I divide by 2. So now I can split my 2 answers apart. I have either negative 6 plus the square root of 292 divided by 2, or I have negative 6 minus the square root of 292 divided by 2. So plug in those in your calculator. Remember, hit negative 6 plus the square root of 292. Hit equals so you get a decimal, then divide by 2. And I get about 5.5. If I do the second one and I do negative 6 minus the square root of 292, hit your equals, so you get your long decimal, divide by 2, and I get about negative 11.5. Once again, a negative is not going to do me much good, so I just want my positive answer here of an x equals about 5.5. Okay. Remember, if it's able to be factored, you usually have pretty numbers, a whole number, maybe a nice fraction on that, okay? All right, last page. Little story problem for us here. It says on the fountain, you're standing at point C, which is 45 feet from the Point State Park fountain in Pittsburgh, Pennsylvania, so I'm outside this fountain. And the distance from you to a point of tangency on the fountain is 105 feet. So that's what I see here. This is 105 out here. And then I want to find the distance from C to A between myself at C and my friend at point A. Okay, I'm having trouble seeing this picture, so let me redraw quickly. So here's my circle. I'm standing outside here at 45 feet away. I have a point of tangency over here, which is 105, and my friend is straight across the circle over here. Okay, they want me to find the distance from C to A. This distance, I'm going to call the whole thing x. So like any of your homework, you want to look and say, do I have two chords, do I have two secants, or do I have a tangent and a secant? And this one looks like I have a tangent and a secant. So I'm going to write down myself this note that tangent squared equals out times whole. Okay. Now, if we want to use the setup here in the book, I'm just going to reverse it. Out times whole equals tangent squared. That's how they're filling this in. So they're saying that the whole thing is CA, or I'm going to call it X, and my outside part was 45. So my outside part is 45, and the whole thing is X. My tangent is 105, and I'm going to square it. So on this side, I have 45x, 105 squared, little calculator work here, 11,025. This one's a nice one. We don't have an x squared, so we're just solving for x. Divide by 45, and I get x equals 245. So we are 245 feet away from our friend. Okay, moving on to our last example. It says in example 4, suppose AB is the diameter of the fountain. Use the diagram below and find the radius of the fountain. Okay, it's the same problem we just did, so let me give you a bigger picture here. Here I am 45 feet away. Here's this 105. I just found across the fountain from here to here was 245. So if this is 45 and the whole distance was 245, looks like I have 200 for my diameter. So my question here is just, what's the radius? Well, if my diameter is 200, don't forget, diameter is also equal to the 2 radius for 200. So if I divide by 2, my radius would be 100. And it looks like I'm good there. So I don't have to do any new math here as far as a new setup with part times part equals part times part, or out times whole equals out times whole, or tangent squared equals out times whole. All right, that's our notes. Very different than our angles and our arcs. 3 setups. You have the notes. They're in there, so you can keep coming back to these. I gave you ways to solve quadratics, but I will give you the heads up. You can factor almost everything on your homework. And I did make a worksheet, so you don't have to worry about this bookwork. So you are going to look at a worksheet again. And as always, if you have questions, email me, give me a shout out, because sometimes other kids have the same questions. And please do your best. Please show me your factoring. Please show me your algebra. I'm going to tell you right now, if you turn this homework in with answers only, I'm going to give you half credit on it. Okay? So if you want full credit on this homework, you need to show me the setup, either part times part equals part times part, out times whole equals out times whole, or tangent squared equals out times whole. And you need to show me the work that goes with it. Answers only aren't going to cut it today, okay? So if you didn't bother to listen to these notes and you don't have that warning, you turn it in, just know you're going to get a 5 out of 10, at the most, and you're going to ask me why, and I'll tell you to come back and listen to this video. So, good luck. One more section of notes for this chapter. We're rolling through it.